Hello and welcome to Talking Pharmaceuticals, an interview series brought to you by Making Pharmaceuticals and Distributing Pharmaceuticals. I'm Victoria Emerton, Conference Director for the events which next take place in April 2025. And in the lead up, I'll be joined by experts from UK Pharma to share insights, opinions and practical advice, providing a fresh perspective on key challenges and opportunities in the industry and to look ahead to their involvement in the events. I'm delighted to be joined today by David Kipling, CEO of Onsite Energy Group. Thank you so much for your time today, David, and welcome to Talking Pharmaceuticals.
Thanks for having me. Thank you.
So David is going to be speaking at Making Pharmaceuticals, and his presentation title is Decarbonising Energy and Infrastructure, and we're going to be talking about that today. So David, could you introduce yourself to our audience and tell us a bit about what you and OSE do?
Yeah, sure. Okay. So the idea for OSE really came from a period of time I spent in a US manufacturer called Jabil. That's Jabil, if you want to look it up. But there was a large global contract manufacturing company. And in about 2010, they identified that energy was decentralizing. So it's moving from historic power plants through to local generation, local supply, even behind the meter sort of factory supplies. And so there was an opportunity for them. It started off actually very interestingly, sort of identifying energy technologies that could be disruptive and play a major part in that decentralization activity. Since then, and after that, we moved into the phase of actually saying, well, why don't we deploy a lot of this equipment in our own factories to get some direct benefit from it ourselves and create demand for the equipment. And that moved into actually starting to deliver energy efficiency projects and identify further savings within the factories, which in Jabil's context also included a medical device manufacturing arm to the group. So we're doing sort of clean room manufacturing of medical devices, and then we were having quite a lot of success with the savings all these technologies were realizing and coming to realize the value of data from our buildings to identify savings. And then we sort of hit the mainstream where we had an opportunity. We'd already proven we could save. We actually saved over 50% of the energy costs in one of our factories, and we were on track to do a lot more. And that's when we hit the competition for capital barrier, where capital tends to like to go to high-profile client-facing projects and not into infrastructure behind, should we say, in the factory. And so, really, the opportunity to support, I suppose, since those days of just talking about decentralizing energy, the agenda has changed somewhat to sustainability and energy efficiency, reducing energy costs and CO2 emissions. The same principles apply, is that there's still a lot of competition for capital. And what Onsite Energy does is it basically, we enable projects to go forward because we fund those projects. Instead of it being an internal capital, it becomes external capital. But importantly, we invest in such a way that it's off balance sheet. And so effectively the companies we work with see both see energy cost reductions and carbon emissions reductions without investment from themselves. So we make the investment, we provide a predictable framework for how those savings will transfer to the customer, and we basically create a partnership that generally lasts somewhere around 10 years, where we implement a series of measures and we work together to realize the value from those measures in terms of both energy cost savings and carbon savings. So in a nutshell, that's what we do. We only work with energy intensive industry, which of course the pharmaceutical sector is, and we're looking forward to meeting quite a few people, obviously, at the event in Coventry. So.
Fantastic. It sounds like you're making energy sustainability a lot more attainable and achievable for companies, which is brilliant. So can you give us an overview of the energy and decarbonisation trends that you can see? Fantastic. It sounds like you're making energy sustainability a lot more attainable and achievable for companies, which is brilliant. So can you give us an overview of the energy and decarbonisation trends that you can see? Fantastic. It sounds like you're making energy sustainability a lot more attainable and achievable.
Yeah, I mean, there's several sort of competing forces, if you like. So if you look back a couple of years ago, when obviously the Ukrainian invasion happened and energy costs spiked, there was a sort of wholesale panic about the impacts this was having on a lot of businesses. I think those energy prices are subsiding now. There's still actually more volatility than before the crisis, and the prices are also higher than before the crisis. But I think generally we're seeing people calming down in terms of the nervousness. There's a bit more of a predictable energy landscape ahead in terms of pricing and so on. At the same time, we're also seeing some other interesting forces at play. Many companies have signed up to things like the Science Based Targets Initiative, and so are committing to milestones for decarbonisation. Some of those targets are now sort of starting to become a little bit more pressing than it was when they made. Some of them are realizing they don't really have answers to get to those science-based targets. At the same time, we're starting to see mandates starting to appear from governments, where some governments are starting to take the stick rather than the carrot in terms of incentivizing change. I think with states of government finances, there's very little in the way of carrots around. Those incentive and grants are gradually dying up. We're still seeing a fair bit of in the likes of Germany, but actually we're starting to see in, say, for instance, in Belgium, they've just mandated solar on all rooftops. You get fined if you don't do a certain percentage of solar on your rooftop at certain milestones. We're certainly seeing rumours in the next round of what they call ESOS, which is a 4-yearly energy audit, effectively mandated on certain that will be mandatory to implement the recommendations, providing they're within a certain payback period. So, all of this is going to there's sort of competing forces. Obviously, we've got a lot of economic uncertainty out there at the moment with what's happening with the US and global trade and so on. So, and the R word is being discussed potentially. And so I think people want to keep their pots of capital dry, but at the same time, they're under pressure to decarbonise and hit those targets they've signed up for, or to avoid these sort of fines. And so, this again is where I think it's really important that the people appreciate there's alternative ways of funding these sort of structures. At the end of the day, businesses operate in a competitive environment globally. Manufacturing costs are important to them to be competitive, and particularly when you're in a business where you can manufacture the same product potentially anywhere around the globe. Actually, manufacturing costs locally really matter to whether a plant stays in that location. Business to other locations globally, and so where we see these trends, what we're keen to do is help people. Our customers address more projects than they would do just utilizing their own capital, and to realize that engaging these sort of projects, most of the project, or every project we do, actually, we do it because it delivers savings as well as decarbonisation. So the two do go hand in hand. You can have decarbonisation and savings, and so there's almost a sort of question: well, why would you wait? If you can actually have savings and decarbonise and don't use your money for the purpose, then obviously that's what we want to we're keen to get the message across and realise that we can be a long-term partner for many businesses to realise their goals.
Absolutely. So good for the planet and good for the bottom line as well. Why would you
Absolutely.
not?
Absolutely.
So you've mentioned that pharmaceutical manufacture is an energy intensive activity. What are the primary issues that you see in pharmaceutical facilities?
Yeah, I mean the major energy load in a pharmaceutical facility is basically HVAC and there's climate management. So whether it's to do with manufacturing, R&D, or even in pharmaceutical distribution, temperature and climate matters, and with that there's a high energy cost for delivering that. So in essence, the way HVAC has been delivered, there's a number of sort of major HVAC players out there. The traditional HVAC approach has worked for years and years, but it's not the most energy efficient way of doing that. And so generally when we go into a facility with in the sort of pharmaceutical sector, there are lots of efficiency opportunities to rethink how to deliver the climate that's required in the facility. Whether it's there's a slightly different approach to producing hot or cold water, or the blending of those to deal with HVAC and humidification and so on. That 50% figure is the big figure to go for. There's no reason why that 50% should be anything like what it is. And so, but I say there's a sort of, we see it also potentially in the data center industry. There's almost a sort of resistance to change in some ways, in the sense of it's always worked, why change it, or if so, why fix it? The reality is there's a massive prize in both energy cost reduction and decarbonisation that is the reason why you should look at it at least and consider it.
So your work applies across multiple industries. Could you give us a couple of examples of work that you've done in the pharmaceutical sector?
Yeah, sure. I mean, we're just doing a work with a production site where they've been challenged with decarbonisation on the site. We're looking at a solution where we introduce some novel heat pumps to produce the heating load, and actually also chilled water. So it's effectively a heat pump that produces both hot and cold at the same time, and with some significant savings. So you're effectively moving from gas-based both heat production and electricity-based chilled water production into a much lower load with a novel heat pump. At the same site also, they're quite electrically constrained, and they sit on a really interesting sort of geological feature, which is one of those things that some people are lucky to have, or some people just aren't aware they actually sit over. But there's the opportunity to do interseasonal heat storage there. So actually, we can produce cold water in the winter and store it until the summer, and vice versa. We can access heat that's not required, say for instance from compressed air, heat recovery, or even the chillers. We can capture and store and use and bring back in the winter. So and that's quite a cost-effective thing to do. Same time, we're also pairing these two technologies up with renewables. The site is actually quite grid constrained and so on. So the overall impact is, I think we've calculated we can save about 57% of their carbon footprint, and actually enable them to go forward with expanding their manufacturing, which they didn't think, or there was a chance they couldn't because of electrical constraints. And at the same time, we're going to save them money as well. So it's a win-win-win. We save them energy, save them carbon footprint, and expand their production for them as well. The other one was, I mean, just an example also is warehousing, pharmaceutical warehousing. A couple of projects where these big robotic warehouses that you may see, they're often sort of 20-meter tall buildings, 22-meter tall buildings, and racked out with a huge number of racks very close together. So it's really only robots that can go down there. If you start thinking about traditional HVAC in that environment, it's really difficult to see how you can actually get uniform temperatures across the whole building. So there's effectively what happens with HVAC generally is when you push air out of an air handler, it goes a certain distance, it loses all its velocity, and it sort of more or less stops the air then. And so what you end up doing is getting lots of hot and cold spots all over the building. So you've got no reliable consistency in terms of the temperature of any particular product in any part of the building. It depends on how close or far away it is from an air handling unit. We have a different technology we work with that effectively the analogy is sort of using if you think about pouring hot water into a cold bath and you use your hand to stir the bath water and it becomes all the same temperature. That's effectively what this technology does. So it doesn't matter whether the building's 22 meters high or 8 meters high or 100 meters wide or 30 meters wide. The temperature becomes the same and the air is in constant motion around all of the objects in it. And so you can guarantee a plus or minus 1 degree temperature difference wall to wall, floor to ceiling, and a much lower energy cost than traditional HVAC. So we're looking to really expand the use of that in things like pharmaceutical warehousing. It's perfect to go along again with renewables. And so the energy costs and the carbon footprint can be significantly lower. And of course, that reduces distribution costs and obviously results in a more competitive product basically in the marketplace. So those are just two examples, one in manufacturing and one in distribution.
Wow, you're going to cover all the bases at the event with all the things people can come and talk to you about. I think it's going to be really interesting.
Yeah.
So what are the applications for innovative technologies and integration with renewable energy?
As I mentioned, sort of like there's a lot of change in the technology in the energy space. Boundaries are being pushed. So, for instance, a few years ago, things like heat pumps had very limited application. They could, a heat pump is basically like a fridge that works in reverse. It pushes heat out, it absorbs cold and pushes heat out. And there's a multiplier effect, so you get more heat energy out than the electricity you put in. But only a few years ago, those were limited to quite low temperature applications, so sort of in the 50, 60 degrees type marks. Now it's very common to be seeing 90 degrees and actually getting high temperature heat pumps that can even do 200 degrees. So for the idea of producing steam and electrifying, if you like, where there's fossil fuels at play, heat pumps become very interesting alternatives to steam production, particularly flash steam production and so on. So there's a lot of new things. I mean, we're finding more and more we integrate multiple technologies together onto the same site. We have our own asset management platform that prioritizes how those different energy sources interact and which ones get priority, so to achieve the sort of lowest cost and balance the system effectively. So I think, as I say, going forward, you're going to find some really interesting technology around heat and heat production and heat recovery. There's a lot of innovation in that space, and equally renewables and the whole intermittency of them. Balancing those up with potentially more other on-site generation sources is another way to go. So little microgrids, if you like, and that's sort of where we focus and try to develop sort of saving solutions there.
There's a lot to talk about on this subject, I can tell. What are the main takeaways for the audience, do you think?
I suppose the number one message is you can have decarbonisation and cost savings. And so, effectively, why wait? There's third-party capital, such as our own, that we want to deploy. That means these projects can happen much sooner. We also bring project resources to the table. So, you don't need to be constrained by your own resource levels as well. We can bring the resources to the table. So yeah, you know, at the end of the day, so one sort of form of business stability, sustainability is being in business, you know, so being more competitive and driving down your operating costs by doing these sort of things is a sensible thing to do, and we're keen to support that. You know, you know, we've got a pot of money. We're looking to deploy about 500 million over the next 3 years, ideally. So we're keen to take on small, you know, sort of big projects and support people's strategy towards decarbonisation, whether that's through electrification or more straightforward decarbonisation activity that's there. So again, other main takeaways, really just the third-party capital can enable activity and progress towards these SBT targets and your decarbonisation goals. Yep, I think those are the main takeaways.
Fantastic. So I think you're going to have a queue of people at your stand at the event, all wanting to find out more. So just to remind the audience that David's presentation at Making Pharmaceuticals is Decarbonising Energy and Infrastructure. You're going to be on stand 824, and I'm sure you're bringing colleagues who will be able to answer everybody's questions.
Yep, absolutely. Look forward to it.
Fantastic. So thank you so much for your time today. Just to remind everybody watching that attending the exhibition and conference is entirely free of charge. Registration is open at www.makingpharma.com. We have an extensive conference programme which can be found on the website, so it's sensible to log on, have a look at what's going on across the 2 days and plan your time when you're with us. So we look forward to seeing you, David, and your colleagues and everybody watching this at the Coventry Building Society Arena on the 29th and 30th of April. Thank you very much for your time today.
Thank you.